Okay, welcome this afternoon, folks, to our very first webinar of this webinar programme around support materials and strategies and approaches to PISA 2025. Really sort of unlocking the sort of black box of PISA 2025 and, any tips and hints that we can get in order to motivate our young people, our young learners, in trying their best when they are doing the assessment in Scotland. On to the next slide, please. So very jam-packed webinar this afternoon. Very quick introduction from myself, which we were just doing just now. We will have a section on PISA 2025 from our NEFR and Scottish Government colleagues. We will then go into a really exciting, and I'm building this up here. This is fantastic. The presentations have been put together by our science, our literacy reading, and also our mathematics colleagues who have kindly given up their time and come on this call to go through some aspects of PISA type questions and how to approach it. We'll then stop the recording, have a good discussion for about 20 minutes, and then we've got final little hints and tips and strategies around practical classroom strategies, and we will close with a short evaluation and looking forward to seeing you at the next webinars. On to the next slide, please, Ian. So I'm going to introduce my colleagues, Keith Dryborough and David Thomas. Keith from Scottish Government and David Thomas from NEFR, National Foundation for Educational Research. And they're going to take you through this short presentation around exactly what PISA is, why it's important, and what the results are telling us. So I'm going to hand over now, Keith and David, and please introduce yourself when you come on the call.
Okay, thanks, Margaret. I'll go first. My name is Keith Dryborough. I'm Principal Research Officer at the Scottish Government in Learning Analysis. I'm a contract manager for PISA, so I work closely with David Thomas, who's about to speak to you from the National Foundation for Educational Research, who we contract to undertake the assessments in Scotland, and I'm also responsible for writing the report for PISA for Scotland. David, do you want to introduce yourself quickly?
Yeah, my name's David Thomas. I'm the National Project Manager for PISA Scotland. As Keith said, I work for the National Foundation for Educational Research based in Slough, just outside London. My main role is working with Keith in making sure the administration goes smoothly and follows the rules of the international consortium. So I work closely with the PISA consortium as well, and therefore have that sort of understanding of the purpose and the processes in the PISA assessment, which will hopefully help you today with some ideas on how to familiarise yourself with those.
Okay, thanks, David. Yeah, Ian, you can move to the next slide again, that'd be great. So just to put this into context, so there's an international surveys timeline, so it's not just PISA we take part in, so there's also the PIRLS, or Progress International Reading Literacy Study, which we've rejoined and taken part in 2026, and the TIMS, or Trends in International Maths and Science Study, which we're taking part in 2028. So there's a whole international surveys landscape now, and PISA is a really important part of that in testing reading, maths and science for 15-year-olds, so we're focusing on that today. So David and I are going to give you a quick rundown of PISA before we move into the domains. So we can move to the next slide.
Okay, thank you, Keith. Sorry.
Oh, I think sorry, additional slides. I'll just jump in this one. Yeah, thanks. So first of all, why do we participate in PISA? So before David tells us more about PISA, and I've structured this starting from pupils. So for pupils, it's an opportunity to practice external assessment skills through quite an innovative online assessment, and it's low stakes, so they don't get the results back, but it's a good chance to do something that's innovative and different. It's a chance to have an experience of representing Scotland in the international study, as well as contributing to a study that helps us better understand our education system. And through contributing, their voice has been represented, their experience has been represented in how we undertake policy. For schools, we provide data and insights back from student and questionnaire responses that can be compared with Scotland and international data. And it's an opportunity for pupils to practice their skills. And through the school questionnaire, it's an opportunity to influence national and international education. And from my perspective, it provides really useful international comparative data on education over time, insights into the factors that support attainment and well-being, has a direct impact on policy development, such as the curriculum improvement cycle, relation to behaviour guidance, and it's also a huge data set that can be used by academic researchers. I'm going to hand back over to David. Apologies if I drop off the call. My battery's close to dying and I've left my charger at the office.
Yep, thank you, Keith. Sorry, apologies, because that was an extra slide that we added in from when we went through it before, so that's why I jumped. If we can, yeah, that's the one I want. Thank you very much. So I'll start with a brief introduction of the PISA assessments, but just to also let you know, you can find out more from the Education Scotland PISA support package, where there's more information and some videos that help you to understand the process and what's involved. So PISA is the Programme for International Student Assessments, and the purpose of it is to really compare the performance of different education systems from around the world. The way that it does this is by assessing the attainment in those specific subjects of a sample, a sort of representative sample of students from the participating countries. And as we said, those focus on the three main domains of reading, mathematics and science. Now, for later in this webinar, for a lot of this, we'll focus on those PISA assessment questions, so you can become a bit more familiar with what they look like and understand a little bit more, I guess, about where they come from and why they're structured the way that they are. The assessment itself has quite a sort of specific age range of students between really sort of 15 years and 3 months and 16 years and 3 months. And the reason for that is it's a focus on students towards the end of their secondary schooling, at the point when most countries are reaching the end of that. So it's a good way of having that appraisal of how their education system has informed those students and developed their educational capabilities. In PISA 2022, the last PISA round that was completed, it was administered to students in 81 countries, and there's a map there showing the worldwide coverage. And I know, for example, more countries in Africa are joining in 2025, so that coverage is extending. And a total of about 700,000 learners all completed the PISA assessment in 2022. So it is a genuine, very large international assessment. One thing to consider when looking at the assessment materials is for the comparisons that are made to be valid, the assessment needs to be a comparable experience for all of those 700,000 plus learners, irrespective of the countries they're in, the cultures they're from, the language that they speak. So the way that it's delivered and the style of the questions is quite controlled by the consortium, so that experience of learners is the same wherever they are, and that guides some of the development, which we'll look at later. The assessment is organised by the Organisation of Economic Cooperation and Development, and as a sort of economic rather than an educational organisation. So it's looking at how learners are developed to take their learning forward into their adult lives, as much as it is about what they have learned. It's what they've learned that's useful for their economic development going forward. And as we've said, the purpose is to provide valid comparable data on what works with it between different education systems, comparing those different education systems there, but also what works over time and how changes in policy or changes in educational background can impact on that attainment. So PISA's been run as a 3-year cycle up to this point since the year 2000, and it's from this year it'll move over to a 4-year period. But it's a very powerful tool at the national level for governments such as the Scottish Government. And I'll pass over to Keith now to explain a bit more about the PISA results that we've got and the important insights that delivers for Scottish education.
Thanks, David. And I won't dwell too much on the results, but these were the kind of high-level headline results. So they're always like a score for each country for maths, reading, and science. And you can see from the charts here that they pretty much go back to the year 2000 to the first assessment. So we can see how performance is changing over time. For Scotland, we're similar to the OECD average in maths and science, but higher than the average for reading. Our scores in 2022 were lower than they were in 2018 for maths and reading, but similar in science. But that was a trend that was seen right across OECD countries. So we move to the next slide. It's difficult to see the slides, but this shows how we compare to other countries. So tracking across maths, reading, and science. So the dark blue countries are countries that are above us in their terms of their score. Light blue is similar to us, and pinky peachy is below us. So you can see in maths and science, we're about average, but there's a number of countries above us. But for reading, we're much stronger, and that's only, I think, 7 countries that are above us. Interestingly, we're similar to France, Germany, and Italy for maths and science, but we're higher for reading. And the country that's most similar to Scotland is Northern Ireland. If you move to the next slide, please. It's worth emphasising that PISA isn't.
David, could I ask you to continue with these slides? I think that Keith probably has chargers. Yeah.
Yeah, I think, yes, I think he was going to say it's worth emphasising that PISA isn't just about the attainment of students, but it also asks a detailed questionnaire about their school experience. And some of those data is presented here. So, for example, 70% of learners felt that they were learned less well at home than they would have done at school. And obviously that's a question that informed us about COVID preparedness from last time. And 60% said their teachers were well prepared to teach remotely. And that information is really useful. That can be linked to the scores that students get, and it can be linked to and compared to other countries. And you can see there the comparison to the OECD average for those things that give us a good background to how students see their schooling and their experience of their schooling. I think if we move on to the next slide until Keith gets back. And this was my slide anyway, so I'll talk about the organisation of PISA in 2025 and some of the factors that may impact on how you see it and what sort of happens in schools and what's going to happen over the course of the next year. So, as we've said, the main focus out of those 3 subjects this year is science. The main focus changes with each cycle. What that actually means in terms of the assessment is there will be more questions on science than the other domains. About half of the total number of questions sat by students will be on science. And there's also a focus on those student questionnaires on science teaching and learning. And there is a school questionnaire as well that's competed, which again will have specific questions on science. There is also a 4th domain that's done in each cycle that changes each time, and that's the learning in the digital world. That looks at real world problem solving using computational and logical skills, using sort of digital tools, etc. The administrative details I won't go through in complete detail, but just to say that there's a representative sample of about 120 schools in Scotland that have already been selected by quite sort of a strict process that's controlled by the consortium. They've been notified of their participation. So you will know if you're one of those schools by now. All of the assessment is performed online. there are 3 sessions that each student will sit, two hour-long sessions on the subject content, and then about 40 minutes for the student questionnaire, which we've mentioned. There are breaks in between. All of the administration activities are arranged with NFER and the schools, and you'll have the information about that we will send administrators into the schools to do that. And one other thing to say on the assessments, that each student will have a different set of online questions put in front of them, and that the test itself is also adaptive in that, depending on the results that the student gets in the first modules, in some of the sort of the multiple choice questions that can be marked straight away, they will be routed either to sort of harder or easier questions, so that to some extent adapts the presentation of the questions to the student as they go through the test. No, I don't know, is Keith back on the call yet? Okay, doesn't look like it. So the last time that science was the main domain in PISA was in 2015. And these are some of the results that we got from that, some of the understanding that we got about the science curriculum from that time. And so this 2025 one is a sort of follow-up to see how things have progressed over that decade. Scottish students were significantly more likely to strongly agree that making an effort in science is worth it because it helps them in the work they want to do later on. Again, that idea of preparing you for later life further on, and that studying science is worthwhile because what I learn will improve my career prospects. Scottish students more likely to support high level of support from their science teachers. So congratulations to those science teachers and teachers in general who are here on this call for supporting their students. And teachers were likely to report that they show an interest in every student's learning in every lesson. And again, there's comparisons there to the OECD average. The teacher gives us extra help when we need it is also reported in true in every lesson for 54% of students. So there was very strong evidence, for example, of good support from their science teachers in 2015. And there's a sort of high proportion of students who expect to work in STEM subjects, science and engineering and healthcare, etc., in the future following that. Next slide, please. So I'm seeing some of these without being totally aware what's on them, but I'll do my best. In science is also divided into various subdomains, and as we go through the presentation, there'll be some talk later on of how the framework that the science questions are based on. There are also frameworks for reading and mathematics as well, how they're split into different components, and those are listed across the bottom of this slide on that graph. Note that Scotland's average score for each science subdomain was higher than the OECD average, and that girls scored higher in aspects of scientific literacy, and boys scored higher in content knowledge and more physics-based parts of the curriculum, such as earth and space and physical sciences. So that gender divide was seen in the 2015 results that we had from that previous study. And next slide. Okay, this was a slide that I put there. So that sort of gives you an idea of the purpose of PISA, why it's useful for the Scottish Government, and some of the insights that have been developed over that. What we're going to talk about a lot during this session is going to be what the questions look like, what students are going to see, and some of the ideas around that. So I wanted to just give you a little bit more background on why they look the way they do. And quite frankly, they are a bit wordier perhaps than what students might expect from their usual experience. And part of this comes from the purpose, and I've provided some information there from the science framework and highlighted some of the key points there. PISA wants to assess how well students are prepared for their schooling, their understanding of science, and help them make informed decisions about science issues, for example, health and environment issues. They do this by developing real world contexts, and they're targeted to be relevant to the students' interests and lives. So almost all of the questions in all of those domains are not just sort of standalone questions. They're based on a detailed context in which the student sort of reads and immerses themselves. So as those new contexts are introduced and describing, especially in science, describing the scientific detail that's required to respond to those questions, that might require a bit more written explanation than you have in perhaps national assessments, where there's a bit more common understanding around talk content. Additionally, those explanations have to be clear in multiple different languages. So as we said, all students sitting the questions can respond in a similar way no matter where they are. And that means that there might be a bit more extra detail or extra nuance put into the question so that every student understands it in the same way, however they're reading it. There's no sort of curriculum shortcuts of this is something that they'll have seen in class. You've got to be more specific about those things. So as I said, we'll go through some of those questions. There's an example of a question there with sort of quite a lot of content packed onto the same page. But I think one final thing to say is remember that this is not, the PISA test is not testing the student, it's testing the education system as a whole. And that's a bit different from sort of national assessments that they do. There's no jeopardy for the student effectively, as there might be in national tests. So you can encourage them to perhaps take time in understanding that context, reading through, immersing themselves in that particular place, and then having a go at reproducing what they think. And just remember as well that this may be a challenge for Scotland's students, but there are hundreds of thousands of students all over the world that will be sitting exactly the same questions in exactly the same way. And it's the comparative difference of how Scottish students respond to these questions that's measured as much as anything else. Right. Okay.
Thank you so much, David. That was excellent. Thank you. Helen, would you like to come in now and start going through some of the real meaty part of this session? So lovely to have you here. If you'd like to introduce yourself.
Yep, absolutely. My name's Helen Scally. I am Principal Teacher of Chemistry at Turnbull High School, and I'm also working as an Education Scotland Associate, and I've been involved in part of a team to come up with some support for the PISA this year. So first of all, I just thought I would highlight that, as David has mentioned, these assessments do look quite different to what young people are going to have experienced throughout their kind of normal assessments in school, and also with the SQA. So it is important that we try and ensure that the learners are as prepared and as confident as possible when they're going into this assessment. It should be an enjoyable experience as much as it can, because it's all contextualized and really relevant to their everyday life. So hopefully they'll get some enjoyment from these questions as well, and applying their science knowledge and understanding in a slightly different way. So if you have a look at some point, you want to have a look at some of these exemplar questions, you can go onto the National Improvement Hub, which has links to the exemplar PISA questions for 2025. You can see that on the slide there where you can find those. And I think Margaret's put a link in the chat already. So as we know, this year, the main domain is science. So that's why there are specific exemplar questions for this year. But there are also questions from the last time science was the principal domain. So that was 2025. And you can see that there's also some questions for reading and also for maths. So we can move on to the next slide. What I'd like to show you is just what it kind of looks like, I guess. This is a science question. This is from the exemplar 2025 questions. And what people at Education Scotland did was they had a look at the level of literacy in this question, and thinking about comparing that with what the literacy level is like for SQA national qualifications as well. And to do this, what you can use is an app called Hemingway Editor, and you just like Google it, stick it in your Google search bar, and it just comes up. And what you can see here is that this website actually uses automated readability index to assess the readability and provides like a grade level estimate. And that gives you an indication of the educational level that's required to understand the text. Now you can see that it's done that kind of by looking at the sentence complexity and also the word complexity. The lower the grade means the text is more accessible and easier to understand. And it says here that grade 9 is kind of a general adult level text. So this particular question, this is the introduction to this question. You can see on the left-hand side, it's coming out with a readability of grade 13. So really it is quite challenging, and you can see that there are some sentences that Hemingway has said are very hard to read. You know, other ones are hard to read, and there's at least one word which could have a simpler alternative, and all of that is kind of building up to give it that complex kind of readability level. So really that is, you know, a sort of something that the young people are not going to necessarily expect unless we give them some exposure to these questions before they go in. And we don't want learners to lose confidence and become worried and stressed in the middle of this assessment. So as we're preparing young people for this and for all assessments moving forward, we really want to try and encourage those resilience skills and the coping strategies, so that if they do see something that is quite challenging for them, especially from a literacy perspective, they're not going to kind of freeze and get panicked. They're not necessarily going to know every single word or the context through which this question is about. And they should know that they're going to be asked about their scientific knowledge and skills, but not always, but perhaps in an unfamiliar context. So we can move on to the next slide. We can see what the National 5 past papers can look like. So this is an example of a National 5 physics open-ended question. And this is how in chemistry and physics, we sort of try to assess like open-ended questions and their knowledge in an unfamiliar context. And you can see that this question is coming out as a readability of grade 7, which is kind of more standard for that age of young person. And you can see it's much more streamlined. So these are the types of questions that young people are maybe going to be more familiar with. They're much more straightforward, simpler, and kind of easy to read. But as David said, there are reasons why, I guess, the questions have been designed in a different way. But we just want to make young people aware of kind of what they're going to expect, basically. So if we just move on a couple of slides, I'm just going to take you through kind of a little bit more detail how this compares with science questions from the SQA in terms of the literacy. And you can have a look at these questions in more detail yourself following the links. So we can just move on to the next slide, please. We're just going to come back to this same question. Okay, so this is the kind of greenhouse effect, fact or fiction. And as we said, this is already kind of quite a high level of readability, so requiring higher literacy skills from our young people. And it's also a little bit different to a traditional assessment because it's online. So that's something that maybe not as familiar with. And also this introduction is quite big and it comes on a separate page to the rest of the questions. So I think our young people are probably more used to having the introduction and having the questions all on one page. They're able to flip and flick between the two. They probably will still be able to do that, but they'll need to navigate using the arrows at the top. So if we move on to the next slide, I've just put a couple of questions in here. They are quite small, so I'll take you through them just very briefly before Andrew goes into some other questions in a bit more detail. I think they should be aware that they're going to be asked about kind of questions to do with scientific inquiry skills, their thinking skills, and also questions about scientific process. But actually, Martin will talk about that later when he does the science bit. And they're going to get some questions that they might expect. So kind of extracting a trend from a graph which supports a conclusion, that's question 1 there. And then also kind of identifying sections of the graph which do not support a conclusion. So those might be straightforward for most young people. But on the right hand side, what we have is a question that's maybe less familiar to them. And I wanted to just highlight that, you know, some of the vocabulary being used just might not be what they are used to. So here we're talking about the trustworthy sort of source that information comes from. And in SQA terms, I think the kids would be used to the word trustworthy, but we'd maybe talk about reliability. There are maybe some words there that I know my learners probably wouldn't be that familiar with at that late age and stage. So kind of things like peer reviewed, journals, consensus. So it might just not come, you know, it might not be straightforward for them, which is good because they're, you know, they're being challenged in this type of assessment. It also might not be clear how many responses are required, and that just adds additional challenge. So next slide, please, Ian. Thank you. So now I'd love to pass over to my colleague, Andrew Thompson. He's a teacher of English at Turnbull High School, and he's going to discuss some of the literacy strategies that we use and that he thinks might be helpful for all learners that are preparing for PISA, and especially when tackling these kind of trickier questions from a literacy perspective.
Thanks, Helen. So I thought I would do a little bit of a section on kind of promoting literacy and how that supports students in decoding these kind of exam style questions. Because I think that as an English practitioner, I always think that, you know, strong literacy makes for stronger performance across their subjects. You know, it's not just a domain of English teachers anymore. Every subject now requires students to interpret, analyse, respond to complex exam questions. And I think if students can't decode what a question is really asking them, then their subject knowledge might not really get a chance to shine through properly. So I've put together a few examples of things that I thought might be relevant in a broader context to address learners' abilities to access exam style questions in regard to PISA. So I think one of the most widely used techniques in schools is the use of command words. So it's a technique that involves boxing a command word, highlighting key topic words, and glancing back to ensure a full understanding of the question. And I'll show some examples of this shortly. So it encourages students to kind of actively engage with the language of the question before even attempting an answer. So for example, in English, a question might begin, you know, analyse how a writer presents conflict in this extract. Students would box the word analyse, highlight presents conflict, and recognise that the focus is on exploring how language and structure convey conflict rather than simply what we often see describing events. So the technique's kind of equally viable in subjects, I would say, like history, where students could be asked to evaluate the significance of an event, or even in science, where they might be required to explain the effects of a chemical reaction. Something that I thought was quite useful as well is common words glossaries. I think they're, you know, often effective in terms of Bloom's taxonomy and our higher level thinking prompts. So they're glossaries that help pupils understand precisely what's being asked of them. So terms like compare, justify, summarize, assess, they're common across subjects, but they can have subtle differences in meaning depending on the context they're used in. So by explicitly teaching these words and their implications, we could equip pupils to navigate these exam style questions in subjects that range across the curriculum. I think a really good strategy for pupils being able to access the questions is looking for context clues. It's a good strategy that helps the learners better kind of understand the exam style questions across the curriculum. So by identifying words or phrases surrounding unfamiliar terms, the students can infer meaning and clarity in terms of what the question is truly asking. So the technique encourages active reading, engagement with the text. It reduces misinterpretation, especially in subjects like, you know, history, science, or geography, where technical or subject-specific vocabulary might appear. So, for example, in biology, and I am not a biology teacher by any means, but a question about something to do with photosynthesis or photosynthetic rate, context clues in that section, such as, you know, light intensity or carbon dioxide levels, could help students link the term to their prior knowledge and guide them towards, you know, an appropriate response. So encouraging the use of context clues empowers learners. They become more independent. They become more confident in tackling, you know, complex or unfamiliar questions, like Helen was saying earlier, across all their subject areas. And lastly, the use of reading comprehension strategies, I think, is really applicable in a wider context. Techniques like skimming and annotating and summarizing are things that we use frequently in English. But I feel that that's useful. My concern is that sometimes it leads to a bit of a trap, as I'm about to show you in the upcoming example, encouraging pupils to skim the passage without indicating that they should read the question given in detail and how to read the question correctly could result in them missing context and therefore kind of providing a correct answer. So with that in mind, I'll just run through a couple of examples of how this could be applied to questions in context. So in terms of this question that I was having a look at, it's to do with Rapa Nui, you know, a topic that will probably be very unfamiliar to a lot of pupils. In terms of context clues, this is part of the passage, but I thought this was a good example. Words like extinct, pupils will bring their, you know, prior understanding of that word, but in context, encouraging them to look around. Things like old, now extinct volcanoes would give them a different interpretation of the word entirely. Boxing words in the question here, such as when and start her research. So here and start her field research. Once pupils have selected their answer, they can glance back at key statements to kind of ensure that the chosen option matches the question's specifications. And this is important because at a glance, because the options here are a mix of numbers and letters, the learners can be inclined to simply match information they find in the passage to the options that are available to them. So for example, down here at the bottom, we have 1990s. And the inclination might be that that's the answer that's present in the passage. Whereas actually, if we box these words, you know, when did she start her fieldwork, it actually leads the learners towards a more appropriate answer, which is actually up here earlier in the passage. She's been there for the past 9 months. Another example that was a little bit more challenging, where this might be useful, is this question here. So refer to the article, click on a choice to answer the question. What evidence do Carl Lipo and Terry Hunt present to support their theory of why large trees in Rapa Nui disappeared? So I think that for this question, a focus on the use of command words comes into play, spotlighting words such as refer to and provide evidence, and then maybe underlining this support their theory. I think that's intrinsic to them being able to understand what the question's demands are. So and lead them to the correct outcome. As a learner, what could have, you know, potentially be my downfall here is that I actually have access to all 3 articles at this stage. So I could have found myself in a position of kind of trawling through all of this information when actually by signaling to pupils that these words, you know, should be highlighted, we can most effectively guide them towards success by seeing this support their theory, a word that would stand out to them. Actually, further down in the article, the words are repeated here to support their theory. And immediately afterward, we actually have the answer that's provided. So that's just a few examples of how those techniques could be used in a broader context in terms of accessing the exam style questions as well. So I think I'll pass you over now to Jamie McDonald, who I believe is up next.
Thank you, Andrew, for that. That was fantastic, really insightful. So Paul and Jamie, would you like to come on screen now?
Hi there, thank you very much. I'm also just going to try and share my screen if that's okay. So I was just going to give a quick overview of how the PISA questions relate to the mathematics curriculum as we've got it here in Scotland, and some of the kind of familiarities that we might kind of be most recognised for our pupils and also for us as teachers, and what we might do to kind of best prepare pupils to answer the questions in that types of context. Generally, overall, based on the mock questions that are provided, the processes and calculations are most similar to an applications of maths pathway. So that's whether that's National 5 applications or even branching into some of the higher applications content. So pupils that are on that pathway or have experience of that pathway will probably be already more comfortable with the types of questions that we see in the PISA assessments. The style generally is on par with National 5 apps, or most of them will start at a National 5 apps kind of level or a context looking, but branch into some more higher order thinking skills, particularly as the questions progress, and we'll look at some examples of that in the next couple of slides. So there's mostly a focus, the questions are mostly focused on numeracy, geometry and statistics, so not a lot of pure mathematics like algebra, for example. So again, that kind of matches up with the content normally delivered in an application style course, but also with the types of content that pupils will experience throughout their BGE will often mostly be focused on numeracy, geometry, statistics types topics, but with a lot more of a kind of focus on literacy and wording and problem solving. So a lot of the questions are a lot more complex in terms of the volume of text that pupils have to go through to try and unpack the problem to sort of discover what kind of mathematical problem it is. There's quite a lot of information for them to take in before they are able to attempt the question. So it's about thinking about the strategies that will prepare kids for that type of question, and what sort of problems are they all kind of used to that will kind of build up those skills required for those questions. So I've picked out a few, I'm not going to go through them all, but I've picked out a few sort of key examples that I think really highlight a few of those points, and from there we'll lead on to a bit of a discussion about what the best methods of support are. So if we can have the next slide. So this one that's been picked out is all about packing boxes into a truck, which is a really well-known and common topic for National 5 applications of maths. It is a whole unit or a whole topic called container packing. So essentially people just have to measure or split into the boxes into the container to fix or to find out the maximum number that can fit into that truck, as it is in this case. And this is a very basic National 5 applications question. So here, to start off with, there's no need to round down so that the boxes are fitting exactly into the container. There's no need to consider different orientations of the box, which is something that we would teach at National 5 Apps, is to go for the different variations. But in this first part, it's very basic, just how much do they fit in, and it's a simple multiple choice of what is essentially the answer, which is kind of what the pupils are used to. They're used to doing a calculation and picking out an answer that matches theirs, basically. So it's a very straightforward process, which is really, really common in National 5 applications. So if any pupils who have looked at that topic throughout their BGE experience or are studying National 5 applications will be able to do that instantly. However, if we move the slide on, when you get on to the second part of that exact question, there's a lot more context involved. There's a lot more for them to unpack and a lot more reading involved. So it goes back to that discussion about the literacy level has to be relatively high for pupils to be able to access this question, because there's a lot more of an explanation into the background of the question and a lot more for them to unpack to actually decipher what it is that the question is asking them to do. And obviously it's the same type of process, but this time, because the numbers don't fit exactly, they're having to deal with rounding or fractions and decimals basically to get the boxes to fit in. And they're also different box sizes, so they've got multiple options to consider here. So a lot of the same skills, but a lot more information to unpack as they go through. And that often can be the thing that learners in maths struggle with, when there are multiple parts to a question, and being able to carry through those multiple parts and retaining all that information as they go through and answer the question. And it's not just a, yes, this is the correct answer, or this is my answer is a number. There's multiple different worded answers, I suppose. She's correct because the medium height is 2/3 of, or she is correct because there's an explanation. And that's quite a key theme through a lot of the questions, is that it's not just carry out a calculation and give an answer. It is a sort of an explanation behind how did you come to those answers. So a lot of higher order thinking skills to determine, right, what is correct and what's not correct, and why is that the case. So really bringing language and literacy, I suppose, more into the questions, which again is something they are more familiar with at National 5 applications than they would be, for example, at National 5 pure maths, simply because of the amount of information and the amount of unpacking of the content in the questions. If we can move on to the next slide. So there's another example of what would be a really basic probability question. So this one has essentially two spinners, and they're asked to compare the probability in both ones. And obviously the probability is the same because it's half and half in both. But this question is asking them to explain their answer, to verify his claim. So he thinks that the arrow, there's a greater probability of the arrow stopping on blue than there is on A than there is on B. And there is an answer, there's a yes or no, but there's also an explain your answer. So it's how do the kids accurately put that information across, rather than just saying yes or no. They have to back that up with something. So some kids will use fractions, or some will use percentages, or some will just try and explain that in words. But again, that's not something they're always particularly confident with, is to give an explanation for an answer, because it involves not just giving a numerical answer. So how do we prepare kids to make sure that they're able to explain their answers, or to use those kind of higher order thinking skills to give an explanation for how they arrived at an answer? So that's a lot of sort of training through higher order thinking tasks, basically, as they go through their curriculum. So making sure that question and strategies are used or built up to allow kids confidence in explaining their answers, and not just giving a yes or no, right or wrong, essentially. And which is what I guess a lot of kids will lean into for maths, is a right or wrong answer. They have to really give an explanation for why they think that is the correct answer, basically. Next slide. So again, this is a build on from the probability question, and I just picked this little bit out to kind of highlight some of the interactive features as well. which hopefully will be something that the pupils will enjoy as they go through. They get a little bit hands-on with some of the maths because they're given little interactive tasks. So this one here is to run a simulation basically on the spinner, so choose a number of spins and kind of interpret the outcomes basically. So they get a little bit of hands-on, but then having to interpret or dig into the results that they've got from that. So using again their sort of problem solving skills to unpack their results and give a sort of a written detailed answer. So again, it's not a numerical answer, it's a written explanation of an answer, more than just a yes or no or a right or wrong basically. So they're having to use their problem solving skills to come up with the answer and then to be able to explain or articulate that answer in the right way, which again is something that's kind of needs to be built up through kind of practice. So giving them opportunities to answer those types of problems where they need to actually explain their answer. And then if we move on, I've got another slide here, but I think you might not have it, but that's okay. If you move on to the next slide, I think it's the very last one, but I'm going to talk about a couple of other little bits as well, if that's okay. So there was a couple of other questions that I'd picked out to look at. Sorry, you can't see them there, and I can't share my screen, otherwise I would show them to you. There's a couple of other things there that, for example, there was one of the questions about kind of forested areas, which gets the pupils to work with a spreadsheet. So to carry out some kind of basic operations with a spreadsheet, essentially, which a lot of pupils might not be particularly familiar with at this point. Some of the kids might never actually have used a spreadsheet at all. And we get that when kids come up to higher applications in maths, which is when they really have to start using spreadsheets, most of them in their school experience. A lot of them haven't had much experience with it at all throughout their school or home life. It's a really valuable real life skill is to be able to work with a spreadsheet. So this is something that's really great exposure for them one way or another, but it's something that they're maybe not particularly comfortable with. So again, that might be something we think about in terms of a little bit of preparation for the kids to have a look at these practice questions and to say, you know, do you recognise this spreadsheet? Do you know what each of these little functions is? Or can you kind of explore your way through the question? And a lot of it will be about exploration and kind of figuring out, based on the context of the question, where they need to apply their operation. So again, not something they might be particularly familiar with, but a good opportunity to kind of explore or to have fun with a bit of maths and a bit of numbers, basically, and really building up those numeracy skills. All the questions you can get on the PISA site for the sample test, or if I put a little QR code there for anybody that might want it, and you can have a little go through to see the kind of types of familiar questions that pupils will be most used to, but also maybe dig in a little bit deeper with some of the wordiness and the more problem-solving questions. So it's really helpful, I think, to prepare the pupils with kind of higher order thinking skills, carrying out those little activities and exercises in their classroom that build up those higher order thinking skills, really exploring problem-solving types of questions, so not just yes or no, straightforward questions, and getting them to think a little bit deeper about why their answers are correct, and as well as that, unpacking some of the language that maybe they won't be more familiar with, because a lot of the questions are quite context based or worded based. So really the language questions are ones where they really have to unpack what the question is asking them, and of course any experience with the applications based course is probably going to be most beneficial. So any learners that have had that experience will probably be most comfortable with the types of questions. But yeah, I would encourage you to have a little play through some of the questions and prepare pupils as best as we can for these experience questions. Thank you very much, and I believe I'm passing on to Martin Cranshaw next.
Thank you so much, Jamie. Martin, do you want to? Yeah, thank you.
Hello, everybody. Thanks. I'm Martin Cranshaw, formerly PT of Sciences at Milburn Academy in Inverness. So Ian, if you can move on to the next slide there. So I'm going to cover what the actual exemplar questions that are available for science aspect of the test. So I'm going to go through each of these three. This is a screenshot taken from the support site which Education Scotland's put up to support the PISA 25. So I'm going to go through each of these three different links because each of them has three different styles of questions. Next. So the first one is the 2015 Science Exemplar questions. These are really nice because they're interactive. And if I was going to be brave enough to try and share my screen, I would try and show you what it's like in interactive. But do you know what? You're better off trying it yourself and get the full immersive interactive experience of these questions. So that's what they look like. So next, there's 5 given there. And so you can work through each of the 5, and I would strongly encourage you get your cohort who are going to be doing PISA 25 to have a go at these in the similar IT room that they will be using for PISA and try and work through them. So next. Each of them starts with an introduction, which I'll come to, but there's always the help button at the top there. So I've highlighted that green question mark. That then takes you onto help screen, which is really useful to show the style of questions that are going to be asked. So there's things like you've got to make and manipulate tables, you've got to drag and drop. So I would suggest you really take all your learners through those particular help screens that they will be able to use during the interactive online assessment. Next. The style of question, as we've already said, there's a fairly wordy introduction. So this for the sustainable fish farming is 130 words. And the as we've seen, the literacy level is quite high. So really encouraging the learners to read through 2 or even 3 times before they start the questions. Our experience is that youngsters will skim, as Andrew was saying earlier, not really take in the keywords. So we've got to encourage them to make the most of that introduction. Next. And so they'll then be greeted with something like an interactive exercise. There's a description next to this, which I'll show you in a slide in a moment. But they've got to drag and drop the invertebrates and the living things to the correct tanks in this fish tank. I found it quite tricky, as you'll see in a moment. Next. So the second set of questions, or the second resource, is the commentary and the background to each of the questions, which is in the interactive set. Next. So this is a big PDF document, which isn't interactive, but it takes you through each of those questions. So there's the fish tank that we were talking about before, which had the drag and drop. And there's a description as to how the aspect of the science framework that's involved, the level of difficulty, and then the comment at the bottom is the most useful in terms of teachers, because it tells you what would be marked correct and what wouldn't be, and things like that. Next. So if we look at the actual question information that was given there, you can see the level of literacy that there is with the type of living things that could be put into the fish tank, and then the comment goes through what needed to be done and what was difficult about it. So you can see that that last paragraph on the comment, which is in the PDF guide, an additional component that adds difficulty is the open-ended nature of the tests. Any 4 organisms can be placed in any of the 3 tanks. There's no restriction on the number in each tank. As a result, there are multiple ways of getting it incorrect. And it's worth sharing with youngsters that these are tricky questions that across the world, everybody sitting these assessments, very few people will be getting 100%. So, you know, tell them it's okay to find them challenging. They've just really got to give it their best shot. Next. The third set is the specific questions for 2025. So these are science questions which are targeted at the 2025 assessment. Is possibly the best inkling into the type of questions that will be asked this year as opposed to previous years. So these are different topics to the interactive question packs from the first 2 links. Next. And you can see here, it's not interactive, it's just a screen grab, but this has got the question and also the commentary on the same page. And if I was honest, if you're trying to introduce PISA 25 science questions to your staff and to your learners, I would probably start with this third set of links here, because I think it's the most accessible to be able to give them an easy in to it. Next. So all these questions are based on the science framework. I would encourage you to have a look at the framework, because it's got these 8 different aspects to it. I'm just going to talk briefly about the science and environmental science competencies, and also I'll come back to the idea of science identity in a moment. Next. So there are 3 science competencies, and you may not be able to see them particularly easy, but there's explaining scientific phenomenon scientifically. There's construct and evaluate designs of it for inquiry. That was the one which, if you remember, the girls did quite well with. And in terms of research, evaluate new scientific information. So it's a different packaging to a lot of the science skills that we already use in Scotland. There shouldn't be much that's news to anybody here in terms of science teachers. The context that they use, you can see on the left-hand side there, they're looking at what that means to the youngster as a person, local and national context, and also global context, because it is obviously an international organisation and they're keen on that outward-looking viewpoint. Next. So I'm going to not go through these in detail because boy oh boy there is a lot of detail, but just to give you some of the key words that are in some of these. So they explain phenomena scientifically. You can see there's words like knowledge, predictions, hypotheses, implications. All of these are things that we involve our young people in a lot of science lessons. So they will have a lot of the skills to do this. I think that when we read the PISA framework, it looks unfamiliar. It's not what we're used to, but it is really testing a lot of the skills that we already have, the existing competencies. Next. Construct and evaluate designs for scientific inquiry. In other words, can you plan an investigation? So you've got to identify the question, your aim, you've got to come up with experimental design, evaluate whether it's working, and interpret the data, draw conclusions. This is not different to anything that science teachers have been doing from BGE. So although the wording might look different to staff, I think you've got to reassure them that what we've been training our youngsters in science will fit them for purpose here. Next. Lastly, we've got the research, evaluate and use scientific information, decision making and action. So again, you know, we're looking at data possibly online or from texts, and you're trying to take a critical eye to that. And again, as Andrew was saying about the importance of literacy, and in terms of maths, the ability to interpret data, these are all skills that we brought to line with this here. So possibly a little bit more involved than we're used to with this, but it sets them up well for SQA national qualification questions with the sort of problem solving, which is in their SQA exams that they will be sitting. Next. And just drawing out the distinctions between our current BGE and competencies and the PISA ones there. The ones in red are ones where we're possibly going to have to build that up a bit. So in terms of BGE, we do explain scientific phenomena. We do explain phenomena scientifically, but it's the other skills that we need to just, you know, that critical analysis of data that we need to make sure that youngsters realize that they can actually do that. And these are mirrored in the environmental science alongside the science competencies. I've just talked through the science ones. There are similar as a sort of parallel strand of environmental science. Lastly, they do have a competence of science identity. Now this is, if you're familiar with Science Capital, then that's, you know, what does science mean to the young person? What is the science in a young person's life? What are their experiences of science? And this is something which is a competence and may be assessed in some ways, but it will certainly be addressed in the questionnaire. So they're interested in terms of how much science figures in a young person's life, and that's their science identity. So next, and I think we're going on to the Q&A.
As we said, the support package, we've put the link in the chat. You have that information. Really advise you to go and look at the exemplar questions, also the information videos that we've got uploaded there. We're going to put another 2 on this week. So it'd be great if you can have a look at those. Please get back to us if there's any questions that you have. There is a link and website information there. On to the next slide, please, Ian. Information, this is just information. We can move on. Very keen to get the sort of strategies and hints and tips. So if we, and remaining, just a wee reminder, obviously we've got 3 more webinars. The one next week is a repeat of this one. So we have tape today, fantastic. On to the next slide, please, Ian. Again, the outline of the page on the ES website, that's in the chat. On to the next slide, please. Martin, would you like to come in just to round off these last 2 slides, please?
teachers, I think it is going to be helpful to raise awareness, show the video, the first one to all learners, so it raises awareness in the school. The second video is for learners who will be sampled, and then make sure that they are familiar with the PISA style questions, and then you can discuss strategies for how to effectively answer them. That, I think, could be done in the course of 1 or possibly 2 periods, and I think it would be worth devoting a little bit of departmental time discussion, because as Paul was saying, there's some real merit in a lot of these questions, and it is making our learners think a little bit more deeply about things. And then, you know, afterwards, recognise the involvement they've had. Really, they're representing Scotland, and it should be celebrated that they were part of the cohort that has hopefully helped to show Scottish education in a good light. Next. So just to finish off, you know, you'll hopefully have a lot of strategies there now from what you've heard from everybody in terms of reading, maths and sciences. Use the exemplar questions, talk through how they're different, and, you know, encourage youngsters to be resilient and to read the question 2 or 3 times and really just to give of their best. Okay, thank you.
Ian, would you like to, yeah, thank you. It was just very quickly, folks, just before you go, I don't want to keep you back too long. There's a really great webinar that's taking place next week on the 29th, and it's actually about strategies for teaching science vocabulary webinar. Just thinking about the literacy that we've talked about this evening, it'd be really, really great for you to go along to that. So information will be shared. It's in this PowerPoint, and Ian, I think that just the last slide. Yeah, we have a very short evaluation of this. What was you know, highlights, low points, what we can do to improve. So please use the QR code. We will be sending out the PowerPoint. We will be sending out the edited video at the end of this with the transcript. And I hope you've had an enjoyable evening, or early evening actually. Ian, just the last slide, which is just a big thank you. Thank you so much, folks, for coming along.